eValid is built using the IE's what's called the Trident rendering engine. So we use the underlying IE browser components. Now, this is a bit of an older machine. I'm using this older machine here. This is an XP box. I'm using this because this has a convenient pair of screens, so I can make the presentation better on this screen. But as you can see, we're running on IE7. eValid runs just fine on IE8 and IE9. To get to IE8, you have to get to Vista. To get to IE9, you have to get on W7. And probably the next webinar we do will be done from W7 with IE9, but it's fine. It works just as well as possible. Okay, it's a self-contained application with record. All of a sudden the machine is behaving slowly. But that's okay because there are a lot of things going on this machine. Mostly it's driving this web server. So there's this web meeting. So there's a record option and a set of playback options. There's a load test button, which we'll talk about, Whaley will talk about when we get to that. There is a straightforward GUI and a set of collection of settings. Looks like this. No need to study all that. There are several hundred different settings that control how things behave. Then there is the obligatory help pull down, which has a thing called a user manual, and I always want to bring that up to emphasize that for those of you who are using eValid, there really is a user manual, and we already know in advance that you will check that yes, there's a user manual, and you'll never read another page from it, even though it has a search documentation, search option, and all of those things. But I just want you to show that there is a user manual. There's a PDF version of it which we update regularly. Every 6 to 9 months, and it runs to about 1,100 pages now. So it's a very complicated product. On the surface, it is very simple. A design criteria of eValid was to make it easy to use for anyone. You don't have to be a programmer, although having good programming knowledge certainly doesn't hurt. You don't have to be a programmer. You don't have to be able to play with JavaScript or C++ or anything. The idea is to make it simple and all the input-output files simple and easy to deal with so that you can interface eValid easily into lots of applications. Another design criteria for eValid was that it had to have very low overhead. It doesn't work if the test engine that you're testing a web application, a mobile web app, doesn't work if that engine consumes more resource than is being used by the browser. You don't want to get the measurements goofed up. And another extremely important characteristic of eValid is that I think uniquely among test engines that are available today, eValid does not, let me emphasize, does not rely on the internal use of JavaScript. Therefore, eValid, when it's working with an AJAX application, it basically sits in a process. It's actually called a thread. eValid sits in a thread that is in parallel with the JavaScript thread that runs AJAX applications. Okay. So our idea is that we can test any web application and we can test delivery to any device. So let's talk a little bit about devices. Okay, let me bring up what I want to show you now. Let me get my screens a little bit better organized here. I want to show you the way we run a user agent string is something as simple as this. And let me bring this up here. Here's the page. It's coming up any second. I clicked it. There we are. Literally, we use if we have two routes for doing this. You can do this while you're in a script, as I'll show you later on. You can open a sub window with an altered user agent string, but in this case, we basically use a batch command, which is eValid, and then there's the argument minus agent, and if you find that quote goes down to there, there's a user agent string for an iPad or an iPhone, and when you launch eValid in that way, you get this kind of a display, and we simply navigate it over and confirm that there it is looking like an iPad. Now, it just so happens that we had that set up as that's an iPad. Let me do an iPhone. I've got a shortcut on the screen which runs a batch command, just like the one I showed you, that opens up eValid as an iPad. Excuse me, iPhone. opens up eValid as an iPhone. He waits patiently for eValid to open up. I guess I didn't click it. Does it show up? What's wrong, Whaley? Hello, Whaley. There we are. The machine is a little slow, and that's, again, my apologies. That's because we're doing this on the with the machine. Now, let me refresh. There is something you have to be aware of, that you have to refresh the screen to get the right user agent string to show up, because all of the eValids that are running share the same user cache. So if I refresh the screen after that refresh completes, I should be able to see that this is now running as an iPad, an iPhone. I think I'm trying to make it look like an iPhone. Yes. So there it is. It's an iPhone. And if I go over to something like www.bing.com, and I will now see the iPhone version of the Bing browser. So here's the PC version of the Bing page, and here's the portable device version of the Bing page. All right. So what I'm pointing out, if I can get my, well, this looks like I've got two of them up here now. I got a little bit too anxious with my clicking. What I pointed out is that we can make eValid with this simple expedient appear to the server as if it is a specific mobile device. And there are, of course, lots of mobile devices. And let me get to another screen here, which I'll bring up, which to show you some of these alternatives. Here is, this comes up quicker now. Here is the same page, which is, I guess, what is it, Amazon? I think it's Amazon. Those are all, yeah, it's the Amazon page, Amazon home page. This was done several months ago in May, actually a year ago. But here are 5 different telephones as viewed by changing, viewed in eValid. All we did was change the user agent string. What's interesting is that there's a very great variety, a very great variance in the amount of material that's downloaded to a mobile device. So an iPhone, here we've got an iPad. iPad is basically downloads the whole show. A Galaxy downloads about a half of the volume. If you go to a T-Mobile, you get only 44 kilobytes downloaded, so you get a much smaller version of the page. The point is that in terms of testing a mobile application, we can test any device you want, and there are, you know, here are some mobile device user agent strings. This is a file where, for example, let's just read the first one. Device is an Avant Go, and it shows all those things. The only annoying feature is that the blanks in the user agent string have to be treated as this %20. That just is an annoyance, but fundamentally you can make eValid look like any device. And then here, even more interestingly, I think, is to look at this case where we have we ran a little script of which you saw that example as the input. This is eValid looking at the same page 203 different ways. I mean, I said to the crew, let's show 200. 100. Well, they said, oh, okay, let's go to 200. We went to 203, and we thought that was plenty at this point. The whole emphasis here is that the whole point of this, and I'm not going to ask you to read all these screens, but notice that eValid can pretend to be, it basically cloaks itself as anybody. Okay, so we've seen 100 devices, comparative download times. I want to show you this other thing here, because now if you look at the download volume, this is where we did a little bit better job of doing the variations. And the Kindle, all of these are navigating to the same page. Kindle, I think, is the smallest one at 9.2 kilobytes, also a BlackBerry. So there's very large variation in download volume and in download times. And we'll see later on what I mean by the variation in download times. Okay. So here is test script creation. we've tried to make this as simple as possible, and I'm going to do something very risky, which is I'm going to try to make a recording in a live webinar. And anyone who's worked in the computer business for more than a few weeks knows that the odds of a successful live test in this situation are not good, but I'll go ahead and shoot for it. I'm going to make a recording, which I will. Now here's the, just cancel. I'm going to press the record button, and eValid says, where do you want to put the script? And, okay, I want to put a thing called test. So eValid will now delete the cache. The reason we delete the cache is we don't want the test to be relying, because we're concerned with performance, we don't want the test to rely on what's already in the cache. We want the test to go out and get new stuff. So let's go here, Facebook home page. Let's try that, and I'm going to click that and see if it goes to where it's supposed to go. And if you're on a mobile device, this is what you see. And eValid, if you look at the script, I'm just going to stop right there and show you the script that's now been saved. And we can talk about the script format also. The script says go to mbing.com. Now, the fact that the eValid is disguised as a mobile device at this point is known to eValid, but not to the script. I'll come back to how you deal with those issues. But we go to m.bing.com and we type in Facebook homepage. There it is. And then we follow a link, and the follow link eValid knows. Remember, eValid is doing its recording from the DOM. So eValid knows to pick up this particular JavaScript function call from the DOM of the page and insert that into the action point for the playback. So I'll play this back, and we can watch the event log get created, the cache being deleted, going to the initial link, which is the mobile link. And there is internal synchronization, which assures all of this happening. And now I forgot to change my times to 0, and I'm going to wait the 15 seconds. So just so you know, the wait times can be adjusted, multiplied up and down, you can multiply them by any number. Waited 15 seconds. There goes the stuff in, and the input text, and there is the result. And I get a nice green screen indicating the status of the event log. And let me look at that event log now. That's a useful thing to look at. The event log shows an example. It shows every status is OK. So there's an OK in the event log. We got all the way to the end. There were 8 OKs out of 8 commands completed, 0 not OK, and a perfectly good OK exit code. So green screen is good. Now green, you'll see later on the yellow screen is also good because the yellow screen shows up when there are warnings. But that's a detail. We'll get back to that. So what we have is at playback time, eValid writes into the DOM as well as reading from the DOM. And if I do something, let's see if I can make this work here. I'm going to do something. I can't change the way the mobile app works, but I want to illustrate adaptive playback. So I want to illustrate that. I'm going to change. I'm just editing the file. Here's the way I edit the file. I click that button, and I'm going to change this follow link to, let's try the second one. Let's change it to 22. Now that index, that index, 22, that index is picked up by eValid using a thing called, and I'll show you how that's done, called the page map. If I turn the page map on and click on this input field, the page map will navigate over to, as soon as I get the screen fixed up, navigate over excuse me, to the specific index element in that page which corresponds to that question, that ID tag. That's for advanced users. For later on, we'll deal with that, but I want to now commit that, and I want to see what happens if I play that script back. And what should happen, what I'm predicting should happen, again, with the subject limitation of the usual concerns about running a test in real time, and now I have that 15-second wait. I should have edited that down to 1 second. I have the usual concerns, but I'm hoping that what eValid's adaptive playback feature will do is fix up the behavior of the application, even though, look at that, it'll fix it up because if I look at the event log, you'll find down in here someplace eValid says, well, warning, can't find the link at number 22, but I'll dig around the page and aha, I found it at 21. So what I just illustrated was one of the most important features of eValid is adaptive playback, which manipulates what the playback does by taking advantage of knowledge, specific knowledge about the web page. And it gets that information from the DOM. I've showed you in the script editor. Okay, now we're going to go on to AJAX enhancements, and I'm going to suppress that one and go back to my original guy. I'm going to use an example that was set up earlier. Script window. I'm going to pick this example, which is AJAX form, and I'm going to check my settings. Now, the settings for each different eValid instance are different. Okay, so the other eValid instance had the wait time multiplier set to 1 or to 0. I'm going to set this to 1. That's good. I'm going to play this script back. This script is an illustration of an AJAX application, which you'll see in a moment. It's called AJAX Pro. And what we're doing is playing around with how AJAX interactions work and how we can overcome problems with AJAX interactions. All right, so we wait these number of seconds and so forth. I'm multiplying wait times by 1. So when it says wait for 412 milliseconds, it waits for 2.4 seconds. And this should give a nice green screen. Should give a nice green screen. Excuse me. With a warning, but that's
Remember,
okay.
Edward, that we are delayed because we are going through the GoToMeeting software. Okay.
Okay. All right. So I'm speaking from my screen. I should wait. Now I see your screen shows the yellow. That's good. Thanks for reminding Rita. So this succeeded, and the only problem was there was some adaptive playback that had to be involved. If I change the record play properties to a delay multiplier of 0 right there and save that. I don't have to commit that to the registry, but I'll save it for this playback. My prediction is that I will get a red screen. Something will not work. And this is an important lesson. Relying on wait times to assure synchronization of an AJAX application is to invite trouble. eValid's non-AJAX synchronization is very nearly perfect. There are multiple signals that are checked every time, but when AJAX is involved, that is, there's an asynchronous process, then the page is ready. But let's just look at let me close that and look at the event log and see if we can see what the error was in the event log. And I think the error is that the property that I'm looking for wasn't there. Now, the reason it's not there is that the AJAX download of that particular passage didn't happen fast enough for eValid to work correctly. So it turns out that there's a very nice solution that we worked out, and I'm going to just bring that up here in the script file and point out to you, again without going into great detail, point out to you guys, you listeners, that what we do is we record from life to minimize the scripting work, and then we look for where things desynchronize. Now, if I go back and find that that last passage was where the playback desynchronized, I can identify the trouble spots and I can make changes. Now, there's a set of commands which we call the structural commands, the structural manipulation, where the user can, and this is not automatic, this is manual, but you can convert you can augment and convert a script in the following way, and I'll just do the first example. Here there's an init link to AJAX Pro, but just to make sure we're on the right page, we manually add a sync on text for the phrase HTML controls example in Windows 0. The original recording said follow link to HTML controls example, and we've now commented that out. So you see the script language is very simple. The # comments things out, and it's a sequence of commands. And I'll just go through this passage right here. Let me get that highlighted so you see what I'm going through. This says make your pointer 0. That's the upper left-hand corner of the page. Page elements in the DOM are numbered from 0 forward, like a good computer programmer. That's the way they do things. The next command says go down the page and find the element on the page where the inner text property or attribute matches the string HTML controls example. When you move the pointer to that number, then do index follow link, okay, which says from that point do a follow link. Now, I won't go through all the examples. You'll find that there are several of them done here, but let's just watch what happens when we play back this script, which now again I haven't changed the wait time. This will go real quick and will give us a yellow screen. So what we've done is we've overcome the inherent desynchronization nature of AJAX applications. In the World Wide Web and in the mobile world, you're going to really want to have that feature in your test playbacks. You're going to be happy with how you look. Is that the way the ad goes? You're going to like the way you look. You're going to like the way this plays back. Okay, so that's a quick, so we've just confirmed, we've added a modification. Okay, let me go on. Now, Whaley is going to take over here for about 10 minutes. Are you on, Whaley? Whaley?
Yes, hello, everybody.
Okay. So you take the screen, and what Whaley's going to talk to you about is how to lift a web application test script that runs on a mobile device into a load test run. Go ahead, Whaley.
Okay, can everybody see my screen?
I see something.
Yes, indeed. Yeah.
Yeah.
Okay. So basically, I already have an eValid browser opened up here. I'm going to simply load an .evl, eValid load test script that I've already created. So, open. And this is a 100 wide with 1 repetition of a particular selected navigational scenario of actions. And so basically, once you load the created load test file, you have 2 facilities to edit the file or create the file from. The most simplest one is the load test scenario editor. So basically, we have kind of like a form fill-in type setup, or you can click in one instance and then add multiples of the same. So basically, if you run across here, we have the script file name, the individual EVS file that I'm performing the load test with, and it's going to use the load type serve type full, which means it's going to serve all the URLs, including pictures and images and everything. And I'm going to use the thin type engine, so we have a full load type and a thin. So basically, the thin is the stripped down version of the eValid browser GUI. 1 repetition, and then we have a data substitution parameter, which allows you to manipulate the parameters within the script as it's processing, and additional parameters that eValid might require for environment setups. And then on the far right is our light version, and that's basically our equivalent of an HTTP ping protocol, which you can program to have anywhere from 1 to 1,000 instances of the light version. So you can spawn off 1,000 threads of going to a particular web page or a series of web pages. I'm going to close that now. And if you look below here, this is the file that was created using the load test scenario editor. And so we'll basically have 100 lines because eValid's going to open 100 eValid browser instances and run or process the test2.evs file. You'll note additionally that at the very top here we have applied an environment variable file, so that sets up environment variables, and then we have the save record. And basically what that allows you to do is save away particular timing data points so that you can do post analysis and graphing. And I'll just give you a quick view of what's going to be inside those files once you've run a load session. So basically the save record places this information into the file as it's running through the load sessions. Shrink this back, and I'm going to go ahead and hit our start the load test and say no now. And so basically now you have your load test screen monitor, and this actively shows you the progress of each one of the 100 separate eValid browsers, so you can kind of get an idea of what's going on. And it's going to take several minutes or so to load up 100 separate eValid browsers onto my desktop, and we can monitor its progress by looking at the taskbar or toolbar below here.
So while one of the features of this particular setup is that it takes about a second per browser user to start, we're going to start them all simultaneously because you're set up with that special sync loop, right? So
Yes.
on this user, all 100 browsers will open up waiting for that particular page to change. So when you click change, they will all march and start in parallel. Okay. And the repetition count, you've got a repetition count of 1, so you're going to just run these once and have them disappear. But in practice,
due to time constraints.
Yeah, due to time constraints. But in practice, setting up a scenario like this, you would put the repetition count of 20 or 30, so that you would ramp up to a certain level, as I'll describe when we see these data after in the next section. You would ramp up to a level and then leave it stable for a while. And because it's this continuous load that most often reveals a serious problem in a web server stack. Okay. Are you up to 100 yet?
No, my desktop only shows 61, so it's slowly building up, ramping itself up. Yeah.
All right.
This web
There'll
environment,
be
web
people
media
sitting around
environment
looking at the
apps.
computer running. Hello?
74 now.
Yeah. Why don't you speak to, while we're watching this go, let's speak to how do we get to 1,000 browser users, okay? Go ahead and explain how we get to 1,000, Whaley.
Oh,
Okay.
so basically what happens is you're seeing 100 instances on this particular desktop. So if we were to slowly ramp this up to 1,000 browser users, this would involve us using 10 other desktops on the same machine. So once you have your 100 instance scenario set up, it's just a matter of propagating it into different desktop environments, and then we spawn all those off at the same time, thanks to the use of our LoadTest playback synchronization page. So the script itself is sitting there,
Yeah.
and we have 100. If you notice on the bottom, we have 100 browsers now. I'm going to put them side by side so you can see all of them.
This is the part that we always draw oohs and ahs with this, because the
And open one so you can kind of take a peek into what's going on in one of them, since they're minimized so small.
my screen doesn't show that yet.
Now it should.
Yeah.
Okay, so I'm going to go ahead and hit the go, and basically eValid, which has been sitting there waiting for the word running on the page, and it knows to start the sequence of actions, is waiting for that sync of text, synchronize on that text on that web page. So you'll note that finally the synchronization has occurred, and it's going to spin through my scenario, which is basically navigating to a particular web application or web page and waiting for results to show up. And they'll slowly disappear as that particular sequence of actions is finished. And you'll note the times being propagated into our load test scenario monitor. Right now, the red shows the longest time or the slowest time that it took. And I believe it should have wrapped itself up.
Right.
Yeah. And then the fastest is in blue at 68.371 milliseconds.
68 seconds. Yeah.
Seconds.
So it took 4 minutes 28 seconds to ramp up to 100. We actually had one of those didn't seem to make it. Probably too much going on with the computer, but that's all right.
May have made it just not the data itself not into our monitor.
Yeah.
Okay, so that was our quick load up for 100 instances of an eValid browser.
Okay, so back to Edward. Okay, do I have to click? I have to click something, Willie, to make me just show my screen. Okay, there we go. So what you saw was the script put into a scenario. You could have multiple different scripts. There's nothing requiring any one of those browsers to behave differently than any other one. There's a simple ramp-up plan, and then you launch and collect the data. I want to go through an example, and that's this one here, which we did a few months ago. And let me show you. Here's what we basically did. We created a script from life, and here is the script. And the script, well, there it is. Okay, we created the script from life, and we augmented it by first off creating we started at no place and started a sub window with the user agent string as an iPhone. The reason we use a sub window is that way it's just, you launch the browser and make a sub window, or you can either use the batch command as I showed you earlier to launch the thing launch the browser as imitating an iPhone. So here's the iPhone. We did a little bit of structural testing, command structures. This is structural testing document object model. We located the inner text that says mobile, and in this case, because of what the website is that we were testing, I use the phrase redacted that. We've sort of censored this a little bit. Let's just say it's a system that is available to a cell phone or a mobile device, and it asks for departures from a location to a destination. So real-time departure calculation, that's a fairly common application these days. So we did this, and we ran the tests. We ran the test in a ramp, as the chart shows. I won't show the EVS file or the EVL files. We basically ran 1,000 browser users starting at one user, incrementing the number of users at 1 per second. That's 1,000 seconds right there. So we get to 1,000 browser users. And once we have 1,000 browser users, we let that stay stable for 15 minutes. Okay? Along the way, and this is very typical of these experiments, this is typical of what we do, there's one critical factor, which is how long does it take between when you start that sub-window to report data, how long does it take? So we did a reset timer right there, and then we used a special command that we have called save record, and what we did is we recorded the user name, the user number, the run count, and the total time, and then this %E measures out the amount of time in each browser's internal clock, the amount of time it required to achieve that result. So what you're looking at is at the end, when there's 1,000 browsers, it's taking almost 5 minutes, 5.5 minutes to retrieve that data. Now, just so you know, there's 5,600, I think the number is in the description, the 5,910 data points. So this chart represents the result of playing back that script 5,900 times on 1,000 different browser users, about 5, 6, 7, 8, 9 times a piece. So we kept that file, and then we just simply took that raw data and dropped it into Excel to produce this picture. Now the challenge is, okay, you got this beautiful curve. Well, what's the story with this website? How can you use that data to make a deduction about the performance of that web application? Okay, you got 1,000 browser users, and when you go, and this is the number, there's 100, and here's 200. It looks to me like when you're 200 browser users, the majority, there are some outliers, but the majority of the data is there at, response time of 30 seconds, or no, that's 50 seconds, so it's like 10 seconds response time. So somewhere around 200 browser users, 200 simultaneous users, all banging on that particular server, the response time starts to grow. And what's a little bit spooky here, there are two versions of this. We think, we actually have talked to the guys who run that website. There are actually two machines involved, and so there's a load splitter. One is a little bit quicker than the other, but the load splitter divides the load into two servers. But at this point, if you look at this chart, if you think about it, what this means is that as the number of users increase, the response time increases essentially linearly with respect to the number of users. Well, what that tells you is you have saturated the channel. So here's an example of where you can make a very simple test. Very simple test. This took probably a half a day or a day or so to get all together. I probably spent more time collecting and analyzing and making all the pretty pictures than we actually did running the test. Here's a very simple test which identified a key performance bottleneck in a web application. So, what we've shown you, the one thing about giving talks like this is that you have to tell your audience what you're going to tell them, and then when you get to the end, you tell them what you've told them. So we really did tell you how eValid works, how it masks itself or comes up with the cloaks itself as somebody else other than the IE browser, and that could be any browser you wish, including Firefox and Opera and Chrome and all that. How we can build a test from a recording on the mobile device using the mobile device interface, which is what I did with Bing. We can, if there is AJAX involved, we can augment the script with special commands in eValid to handle the potential desynchronizations from AJAX. There's a simple way of lifting such a test into a load test scenario and ramping that up to any number of users you wish. I think our personal company limit maximum now, I think we've done about 8,500 users on 10 machines. And I have to tell you, we use machines in the cloud to do that. And then lastly, here is a conclusion that you can come to from a very simple graph. So that's the story that we're trying to get across. We don't think that mobile testing is difficult. We don't think that it requires zillions of dollars. It certainly doesn't require a room full of PhDs hacking away on laptops, or what was it, a Facebook hackathon? I saw a news article about that. I'm not sure I believe that a hackathon is anything more than a fancy way of having doing texting in a beer bus. But anyway. But you don't need that. One or two people can build very sophisticated tests very easily.